Welcome to qnawire.
So this question tells us that for copper at a temperature T of 300 Kelvin, to calculate the probability that a state with energy equal to 99% of the Fermi energy is occupied. So if our energy is 99% of the Fermi energy, we can just describe that as, well, our energy E is going to be equal to 0.99 times by the Fermi energy EF. The only other bit of information we need is that in this textbook, you will be given the Fermi energy of copper at 300 Kelvin, which will be around 7 electron volts. So to work out the probability, we need to consider the Fermi-Dirac distribution, or the Fermi function as it's also called. Now this Fermi function, which we will call lowercase f with respect to our energy E, is equal to, well, we have 1 over 1 plus the exponent of our energy minus the Fermi energy, and that is all over the Boltzmann constant K multiplied by the temperature T. And this function will simply just tell us the probability of a state E being occupied at a given temperature T for a metal. So substituting in some values, we can find that this is going to be equal to 1 over, we have 1 plus, and now E minus EF will be minus 0.01 EF. So that comes out as E to the minus 0.01 E subscript F over KT. So now we can plug in some values and see that that's going to be equal to 1 over, we have 1 plus E to the minus, well, we have minus 0.01 times by our Fermi energy for copper, which is 7, and that will be over our Boltzmann constant, which is 1.38 times 10 to the minus 23 in base units. And that will be times by our temperature, which we are told is 300 Kelvin. Now this comes out as, when you punch it into a calculator, to be 0.937, or in other words, 94%.